Okay, so we're back here, and we left off with number 3, and we talked about what's called the conjugate pairs theorem. In number 4, they say it's a third degree, so you should have 3 solutions, 3 zeros. One of them is real, that's 4. One of them is complex, 3 plus I. Well, we always know the conjugate has to be a solution as well, so it's 3 minus I. So there's your missing answer for that. All right, so let's flip it on the back. And we're not going to do all these, but let's take a few more examples here. Let's do number 5. Number 5 is kind of a cool problem. The reason why this is interesting is that you might be able to solve for one of the answers right away. Because you only have one x term, you might want to just add 27 to both sides and say that x to the third equals 27, and then to undo a cube, we take the cube root of both sides. Now that's not a bad way to go. You get x is equal to 3. The problem is that's only one solution. Because this is a cubic equation, because the degree is 3, you actually have 3 solutions. So where are the other 2? How do I get that? Well, let's do this. Let's take 3. Let's use synthetic division and see what we get left with. This is 1x to the third. Notice that we're missing the x squared term and the x term. So I'm going to put 0 for x squared, 0 for x, and then negative 27. All right, so the 1 comes down. This will be 3. Add it, multiply, add, multiply, add. Okay, there's 0. That's what we were expecting. So one solution is positive 3. Now what's left here, this is x squared plus 3x plus 9. And I'm going to solve that. So now it's a quadratic. The reason why you want to get a quadratic is because now you can do quadratic formula. You have other methods. You might be able to factor. In this case, factoring is not going to work. So let's say a equals 1, b is equal to 3, and c is equal to 9. And the other clue is that if we go to y equals and we graph this, x to the third minus 27. How many zeros do we see? Well, we see 1. And now you can zoom out to make sure you're seeing everything. But we only have one real 0, it looks like. Well, we should still have 2 more. What that means is the other 2 are probably complex, imaginary. All right, so let's go quadratic formula. X equals the opposite of b, plus or minus, square root, b squared minus 4 times a times c, all divided by 2 times a. Now we're going to get negative 3 plus or minus. When we work out the radical, when you do this, you're going to get negative 27 over 2. Poke out the I. Now the square root of 27, you can actually break that down and simplify. That's 3 times 9, 3 times 3. So we have a pair of 3's. So what we end up getting out of this, so we pull out the pair of 3's, and we'll still have 1 3 left over. So we're going to get negative 3 plus minus. Okay, I'm just going to rewrite. That's 3i square root 3 over 2. Now that's kind of a mess right there, but those are going to be the other 2 solutions. So we've got positive 3, we've got negative 3 plus 3i root 3 over 2, and then we've got negative 3 minus 3i over 2. Oh, don't mind the bell. Okay, so those are our 3 solutions there. Now, if you're trying to solve by graphing on the calculator, you're not going to get the complex solutions. You will get the positive 3, but you will not get these. So that's where synthetic division can help you. The goal with synthetic division is to break down your polynomial until you can get to an x squared, because then you have the quadratic formula. Let's do one more here. Let's go ahead and take number 9. Okay, now you can do the rest of these. if you like. So we've got y equals 4x to the fourth plus 7x squared minus 2. We're going to take a look at it. Let's see if we can find any zeros from where they're crossing the axis. Well, it looks like we got 2 here. If we zoom in a little bit, see if it shows us a little bit more. Okay, well, it looks like this is between 0 and -1, and then this is between 0 and +1. You can try to guess on it. Maybe it's -1/2, maybe it's +1/2. I don't want to guess, though. I'm going to save myself time by actually going second and trace. And I'm going to find the 0. And if I want to find the 0 on the left, left bound, right bound, enter. So there's -0.5. Okay, so that it is -0.5. Let me do the same thing for the 0 on the right. So I come over to the 0, left bound, I go left a few spaces, enter. Okay, right bound, I go right a few spaces, enter. I don't need to guess. So -0.5 and +0.5. So there's 2 answers right away. So I'm going to, down here, I'll put negative, I'm going to write it as -1/2, +1/2. Now I'm anticipating 4 zeros total. Looks like they're going to be imaginary, which is fine. We got the 2 real ones, we need the other 2. To do that, I need to break this down. So I'm going to take -1/2, and I'll use synthetic division. So it's 4x to the fourth, 0x to the third, 7x squared, 0x minus 2. I got to put the zeros in those empty places. So 4 comes down, multiply by -1/2, that's -2. Add that, multiply that, that's 1. Add, that's 8. Multiply is -4. Oh, sorry, add -4. Multiply that is +2. -2 plus 2 is 0. Okay. Now, that's one solution, like we thought. Right now, if I wrote this out, the depressed polynomial equation, this would be x to the third. I need to break it down into an x squared. So I'm going to do synthetic division again. Now, I already used this solution. I'm going to use the next one, 1/2. So +1/2, I'm going to use 4, -2, 8, and -4. I'm going to use the cubic equation now. 4 comes down, multiply that, that's 2. Add that to 0. 0 times anything is 0. Add that is 8. 8 times 1/2 is 4. -4 plus 4 is 0. Okay, so we have, there's our second solution. Yep, that works. Now, what's left here, I'm going to move into this next space just because I'm running out of space. This is 4x squared plus 0x plus 8. That's the quadratic. So 4x squared plus 8 is 0. Now, normally I would say, go ahead and do quadratic formula. However, because we don't have the middle term, let's move the 8 to the other side of the equation. We can isolate the variable on one side, because there's only one term with the variable, put all the other numbers on the other. So divide by 4, we get x squared equals -2. And to solve, to undo an x squared, we're going to take the square root of both sides. Now, even though that's a negative number, we can still take the square root, it just means we're going to get i's. So we get x equals, when you take the square root of both sides, don't forget that you get 2 solutions, plus or minus. Now I simplify here, that's like a -1 times 2. The square root of -1 is an I, so I poke out my I. What's left is the square root of 2. I can't simplify that anymore, so those are my other 2 solutions. So I have -I square root 2, +I square root 2. And that is your answer. Now the last thing we'll talk about, we'll come back up here to number 7. We're not going to do it, but let's just talk about it. So f of x, and they give you a cubic equation, third degree. One of the zeros is negative I. Without doing any work, we know that another zero is the conjugate, which would just be positive I. This is like 0 minus I, so the conjugate is 0 plus I. So you already have two solutions. Because it's a third degree, there's going to be one more. And in this case, it's going to be a real number. What I would do is go to the calculator and graph it. And then if you have to find the zero, you can use the calculator function to do that. Okay, so if they give you a complex zero, you already know another one of those. You know it's the conjugate. And that's the end of the notes.